Welcome to our Beer U module on vital stats. In this module, we'll look at some of the more significant beer metrics that will help you to understand beer and the brewing process. We'll talk about measuring beer color, density, and alcohol, and then we'll talk a little bit about why those things are important in the world of beer. Beer is statistically measured by a number of criteria, but three basic measurements are used more often than others. Understanding these measurements, how they are determined, and what they mean is very important to understanding beer. These three measurements are SRM, or Standard Reference Model, a measurement of beer color; ABV, or Alcohol by Volume, a measurement of the alcohol content in beer; and IBU, or International Bitterness Units, a measurement of the bitterness of a beer. The first thing we sense about a beer is visual, the beer's color. This is measured in degrees SRM. Most beer styles are fairly uniformly spread out along the SRM scale and range in degrees from 0, which is completely colorless, to somewhere just over 40, which is black. The scale itself can actually go much higher than 40, but beers rarely measure above 44 or so. Malt provides most of the color in beer, so SRM is really a measurement of malt and is a good indicator of the types of malt used. Specifically, SRM is a measurement of the absorption of light of a beer, which is determined by how much light of a particular wavelength passes through 1 centimeter of the beer. Fortunately, we don't need to be scientists to understand all that. We can just look at the beer and see what color it is, and by comparing the beer to an SRM color chart, we can easily approximate the degrees SRM. SRM is a very good representation of beer color, but it is a measurement of only one color in a beer, and many beers have multiple colors in them. A porter, for example, may be mostly brown, but also contain many ruby highlights. SRM is designed to measure the most dominant color in beer. Measuring SRM scientifically involves the use of a spectrophotometer, which measures the light as it passes through a small sample of the beer. It's not really critical to understand the SRM scale or to be able to calculate it, but SRM and color is usually the very first impression that a beer can make on anyone, so it can be very important in how a beer is perceived. Color can be a good indicator of what flavors to expect from a beer. Taste is probably the most important aspect of a beer, and while color doesn't guarantee a particular flavor, the color of a beer is generated by the malts that are used to brew it, and those malts contribute a great deal of a beer's flavor. Pale-colored beers are generally going to taste of pale malts and the bready and biscuity flavors that are associated with them. Amber and copper-colored beers will likely taste of the toasty, caramel, or toffee flavors associated with darker malts, and brown and black beers will likely taste of the chocolate, coffee, or roasted flavors that the darkest of malts provide. Specific gravity is a very important measurement for a brewer. It is a measurement of density compared to water, and it tells a lot about the beer. On a gravity scale, pure water is 1. Adding any solids or other materials to water generally creates an increase in the water's density, or gravity. However, alcohol is actually less dense than water, so adding alcohol to water actually reduces the overall density, or gravity. The gravity of beer is always measured at 2 different times. Both are measurements of specific gravity, but they take place at 2 different times and produce different results. First, the gravity is measured just before the fermentation begins. Because all of the solids and other components are now in the beer, and no alcohol has yet formed, specific gravity will be at its highest just before fermentation. This measurement is called the original gravity, or OG. A second measurement is always taken after fermentation is complete. This measurement is called final gravity, or FG. Because many of the sugars in the beer have now been converted to lighter density alcohol, this gravity measurement will always be lower than the original gravity measurement. Because of this change, the comparison of the original gravity to final gravity is essentially a measure of how much alcohol was produced in the fermentation process. By the way, the specific gravity is usually measured in beer with a device called a hydrometer. The hydrometer floats in a sample of the beer and indicates the specific gravity based on how high or low it floats in the beer sample. Specific gravity is much more important to a brewer than it is to a drinker. It helps to define much of the nature of the beer and the finished product. In the end, measuring the specific gravity of a beer is how a brewer determines how much alcohol it contains, so it's a critical statistic. Sometimes a brewer or a beer consumer wants to caution people that a beer contains more alcohol than usual, and the term high gravity is often used to describe those beers. It's called high gravity because the original gravity is generally higher than average, meaning that there is more sugar in the beer that can be converted into alcohol. European brewers often use a different measurement of specific gravity known as degrees Plato. Plato is actually more accurate than specific gravity for brewers because it measures the specific amount of sugar in beer, which is why brewers measure the density of beer to begin with. However, specific gravity is still more popular as a measurement in the US than Plato. Beers can contain widely varying amounts of alcohol, and it is important to understand how much alcohol a particular beer has. The most common measurement for this is ABV, or alcohol by volume. ABV is largely accepted and used around the world. ABV is a measurement of the percentage of alcohol contained in a beer. A 5% ABV beer is composed of 5% alcohol and 95% water and solids, measured by volume. Because alcohol is lighter in weight than water, this makes the ABV measurement different than simply measuring the weight of alcohol in a beer. And because of this difference in weight, ABV will always be higher than ABW, or alcohol by weight. For example, a 5% ABV beer is about 4% ABW, or alcohol by weight. ABV is often measured by brewers with a fairly simple equation that approximates the true ABV. The final gravity, or FG, is subtracted from the original gravity, or OG, then multiplied by 131. Here's an ABV equation sample. To determine a sample ABV, we could multiply 131 times the original gravity. Let's say 1.056 in this case. But we need to subtract the final gravity from that first. Let's say 1.010. This would leave us with an estimated ABV of 6.03 for this hypothetical beer. ABV is an important statistic for a beer for several reasons, but the most important purpose of understanding ABV is just to know what you're drinking. How much alcohol are you consuming per beer when you are drinking? Most modern mainstream lagers contain around 4 to 5% ABV. Since these beers account for a very large percentage of all the beer consumed, many people get used to that sort of alcohol content and base their perceptions about beer on that. But many craft and specialty beers can have a much higher than average ABV, so it can be important to know what you're getting into before you try to drink them. An American Pale Ale might clock in at about 6% ABV, a Doppelbock around 8% ABV, and a Russian Imperial Stout might contain 12% ABV. So be warned that a single craft or specialty beer might contain 2 or 3 times as much alcohol as a mainstream lager. Another key measurement of beer is bitterness, which is quantified by the IBU, or International Bitterness Units. The IBU is approximately equal to the EBU, or European Bitterness Unit, and the values are mostly interchangeable. IBUs are a chemical measurement, not a true measure of perceived bitterness. So a beer with a high IBU level might not taste terribly bitter if it is also a very malty beer, as the malt content would tend to balance out the bitterness. Conversely, a low malt beer with a moderate IBU level might taste very bitter since the malt is not present to balance it out. Bitterness for any beer is determined by the hops that are added to it. The contributing element in hops that provides bitterness is the alpha acids in those hops. So understanding the hop variety and the percentage of alpha acid in that variety is critical to determining the IBU. Higher alpha acid content hops will increase the IBU level faster than hops with a low alpha acid content. The calculation for IBUs is much more complicated than the calculation for ABV since there are several contributing factors. The relative amount of hop ounces added to the beer, and the percentage of alpha acid content in those hops, plus the length of time a beer is boiled all figure into the equation. Boiling hops modifies or isomerizes the alpha acids, so it is important to know how long the hops were boiled as the bitterness levels change in that process. Additionally, different kinds of hops are often used in the same beer, so the equation needs to be repeated for each type of hop being added in order to account for the varying alpha acid content. The IBU scale theoretically measures up to 110 IBUs, but humans generally cannot taste IBUs beyond 85 or so. IBUs don't truly tell you how bitter a beer is going to taste. It can be a good indicator, but it's really just a chemical measurement that may or may not be very accurate in representing the finished beer. Having said that, IBUs have become something of a cult measurement, even among brewers. It's a measurement that has taken on a lot of perceived meaning, as some people judge much of a beer's worthiness based on the IBU value of that beer. Sometimes it becomes a sort of my beer is better than your beer type of boast for a brewer or a drinker. Some brewers even claim IBU values well beyond the theoretical 110 IBU saturation limit in order to point out how bitter their beer might be. Here's a bit of advice. If you enjoy some high IBU beers like I do, that's great. India Pale Ales and Imperial India Pale Ales are some of my favorites, and those beers are high on IBUs. But don't make your beer brand decisions all about the IBUs. Taste your beer and decide if you like it, even before you look to see how many IBUs it might have. More isn't always better. Congratulations! You've finished the module. Hopefully you have a few minutes to take the optional quiz that is coming up. Like I said, it's optional, but if you are taking a Beer U curriculum and need to get credit for this module, you'll have to take the quiz and get at least 70% of the answers correct in order to show this module is complete. Good luck!